Hello everyone, welcome to a brief walkthrough of the assignment 7, which was the recursion problem. To get started with this assignment, the first problem was asking us to create a rect less than. This is going to take in an integer and prints a less than symbol pattern using the asterisk character. So the parameter, the n integer, is going to represent the largest indent of the pattern. And when we say indent, we refer to what this is going on right here. So if I put this in tree, I'm going to have tree spaces of indents before I print out my parameter. So to go ahead, what we could first attempt to do is try to get this logic working where we go down to a base case and then return to what we previously had as n, in the case of storing the numbers we used to have. And to do this, our base case is most likely going to be when our n is going to be less than or equal to 0. And why we do this is right here it says if n is 0 or negative, the function doesn't print anything. So when we get this last scenario, that is where we have our base case, and that's where we're getting this logic from. Now what happens if we have nothing to do? We're just going to simply return. And now what we want to do is attempt to do a recursion. So our recursive step here, before we actually start printing out anything with numerical values, why don't we just print out n? And now what I'm going to try to do is do a recursive call on n after I run this. So you could see here that if I try it with 5, I go back down to 1, and then that's it, and then it ends. And what I want to do is go back from 1 all the way up to 5 again. Now, how do I do this? Well, essentially what is going on is that n is being reduced and it's going down each time. And once we hit this base case, we return. However, this is recursive calls. So if we put anything after this code here, because notice that we're not returning anything here, if we put anything after this recursive call, it is still in the call stack on the way back. And what we mean by this is that if I put a print of n after this recursive call, you'll see that I go from 5 to 1, and now from 1 to 5. Now again, this logic happens because these print statements are still in the code that needs to run after this statement. However, if I put a return right here, you'll notice that it actually goes back to how we used to have it, because the return ends our code and it doesn't let us go back there. Cool, so now what do we need to do here in order for our ends to not print out spacing and instead print out the indents? Well, why don't we just try printing out a blank space times the value of n. So essentially blank times n. Let's try running this. You'll notice that it looks like I'm getting the space there, but I'm not getting any asterisks. So what do I need to do now? Well, if I'm trying to do an indent beforehand, this is how I would do that indent. And if I don't want to do it that way, what I can do is concatenate an asterisk onto the end of my evaluation function right here. So now if I run this guy, we'll see that I get the asterisk going to the right to left and then returning to their original place. Great. And this looks pretty good to go for that one there. Now we're going to have a similar one where we take in an hourglass shape. Excuse me, sorry about that. This hourglass shape is going to take in a character and two integers n, and these two values, one is going to represent the character that we're going to print out, and then the second parameter is going to be the indent. So now the number of the characters in the top line of the pattern and in the bottom line of the pattern is n. So if we see here, if we put in 10 over here, 10 is going to be present here and here. And then let's see here, the indent parameter represents the indentation used in the first line of the pattern and in the last line of the pattern. So essentially how far was going to be shifted out from the side, and then from there how we get it reduced. Now let's go ahead and get started here with our if statement. We can see here if n is 0 or negative, or one of the characters is the empty string, the function doesn't print anything. And then you should say here, you should assume that the indent parameter will be non-negative, i.e. is greater than or equal to 0. And now we can see here, let's just go ahead and try to get started with our first if statement. The base case here, if n is 0 or negative, or one of the characters is the empty string, we shouldn't print anything. So let's go ahead and do this statement here. If n is less than or equal to 0, we don't want to print anything, so I'm going to return. And now we'll see here that this logic is pretty similar to what we had earlier, where we go back down and then return back out. So what we want to do first is attempt to bring an indent out. So n is going to, excuse me, I is going to represent the indentation on each of these lines. So I'm going to say I blank space times I. Again, this is very similar to what we did up here with our indentation earlier. And now what I want to do is try to print out how many characters are there. Print out C a total of n times. So again, if my C is an asterisk and my n is a 10, I have 10 asterisks. So how do I actually print out the amount of characters n times? Well, what I can simply do here is I can concatenate n times C to my overall logic there. So now if I try to run this guy, we'll see that I'm getting, looks like 1, 2, 3, 4, 5 items at the very top. And let's see, our glass shape is asterisk of asterisk 5 and 5. Why don't we try doing it with 10 and 0 so it looks a bit like the logic that we have there. And cool, it looks like we're getting 10 at the start, which is an okay start. Now, an issue here, though, is that I'm not doing any recursive calls. So I'm going to try to do next is do my recursive call, rec hourglass shape. And how do I get to my eventual base case here? Well, what we used to do is n minus 1, but an issue here is that we have 3 more parameters. So the first parameter here is our character, and should our character ever change when we're doing this recursive call? I don't think so, so what we're going to do is just simply add back in the character C into our code. What happens for n minus 1? Well, n is the amount of digits that are printed out. And if we look here closely in our PDF here, we'll see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 asterisks at the start. And if I go down here, it looks like I have 8, 6, 4, and then 2. And it looks like it goes ahead and does the inverse. So what happens here is I'm actually removing 2 individual characters each time. Now, how many characters do we figure out we're going to print out? Well, we're going to print out n characters. So if I'm removing 2 each time, I'm actually going to subtract 2 from the scenario here. Now, what happens if we just leave our indent with I? And let's see what happens this way. We'll notice that our indents, it looks like we're removing the 2 characters properly, but we're not ever shifting this over. And it looks like what needs to happen is that this needs to go 1 over, and this needs to go 1 over underneath this one. So essentially, instead of just reducing it by I, we're going to increase it by I plus 1. And now we'll see that we're actually getting this kind of triangular format where it's going down. Now, what did we do previously with our other print statement? Well, essentially, we're going to do the exact same underneath it. And when our recursive call is done, it is going to go ahead and repeat what was there earlier. Awesome. So now our third problem here was this rec adder. Rec adder is going to take in a list as a parameter and returns a number with the sum of all integers and floats found in the list. And recall that you can determine whether item is an int or a float by writing type of item is equal to int or type of item is equal to float. Now you can see here that we can test it with other inputs, but easily enough, we have this where it's only the top level list, so we don't need to look at anything into the list. Now, what is going to be our base case here? Well, if we're doing recursion on lists, the general base case is making sure that the list is going to be empty. So we're going to try to keep reducing our list until we hit a size that is empty or 0. And if my list is at 0, the length of it, I'm going to return a 0 because what we're doing here, instead of just returning normally, nothing, and we're printing out things, what we're actually trying to return is the numerical values that we're adding up. Now what we want to do here is use these 2 types of logics with type of item and then type of item of float. And item in this scenario isn't going to be item like so. It will actually be called list of 0. Now we can also technically do item is equal to list of 0, like so, but it's easier to just do it this way. Now if my type of list of 0 is an integer, or my type of list of 0 is a float, what we'll notice now is that we're actually getting access to one of these values, like 1, 2, 3, or 4. Now, what do we need to do if we notice that the list of 0 item is something that we can add? Well, what we're going to try to do is return that list of 0 item, and returning it will essentially say 1 or 2 or 3, or in this scenario 10, 20, or 30. And if we're trying to add up all the numbers inside of here, what we want to do is add this list of 0 item onto the remainder of the list with its recursive call. So the way that we do the remainder of the list again is by getting the first index and then setting it to the remainder of the items there. And again, this works because our base case checks if our list is empty, and if it's not, we can access the remainder of it. Awesome. Now, if this doesn't work here, what we need to do is essentially say, okay, well, the list of 0 item is not 0, so what I'm going to try to do is skip it. And how do I skip it? I simply say, go ahead and add in the remainder, do a recursive call, return the recursive call of recAdder, and this will put me back into my list up here. Let's go ahead and run this one. And it looks like with our simple code here, we get 0, 15, 0, 5, and 100. Awesome. So that looks to be going pretty well for us with our adder. And now what we're going to try to do is do this logic here of even count number. Our rec even count number is going to take a one-dimensional list of strings as a parameter and returns the count of even numeric types, float or integer, that are found in the list. Now, what we could do here again is an issue that occurs is that not only do we deal with floats and numericals, so we know how to check for those, but we might also encounter an issue where we have strings inside of it as well. So what we're going to try to do here is essentially something really similar to our list logic up here. So what we could start out with again is if my length of my list is equal to 0, I'm going to return a 0. And again, the reason I'm returning 0 again with these counting variables is because we're adding up these return statements. So we need to make sure that we return a 0, because if we return blank, this actually returns none type. And that's not what we want, right? What we want to do is simply return a 0 so that we can add it on later. Cool. So now, very similar to our logic that we had up here, we're checking if the items in our list are of type int or of type float. Now, if they are, what do we need to check next? Well, not only do we need to check if they are a float or an int, we also need to check if the list of 0 mod 2 is equal to 0. So what this means is that if I divide a number by 2 and I get no remainder, that tells us that it's an even number. And what happens here if it is an even number? Well, what we could say next then is I'm going to return a value. And again, this is just counting up each individual occurrence. So if I'm trying to count the numbers, I'm just going to return a 1 plus, and instead of up here, we return the actual value of list of 0. What we're trying to do here is not return the actual value, but just a counter variable. So I'm going to return the rec of even number counter to the remainder of the list that I have there. Great. Now, if I do this properly, I will be able to be counting up each of these values. Now, what happens if I don't have this if statement working for us? I'm going to go ahead and say else, return. And what am I going to try to return? I'm just going to try to return the recursive calls on the remainder of the list that I have present in my code. Cool. Now, it looks like we're getting a little error here. Unsupported operand types for plus, int, and none type. And the reason why this might be happening here is that I'm returning my 0 over here. And it looks like if my if statements aren't running, so it might be a scenario where my if statement over here is actually not running and I get a 1. And then my else isn't running here. So if you're encountering this error where you're getting this none type, one approach that you could try to do here is attempt to remove that if statement and just simply return the statement down here. And it looks like removing that else statement actually solved it for us, where it wasn't running all the time, but now it looks like it is. And it looks like we're getting tree each time in our code. So this guy's good to go as well. Now for our last one here, looks like this is the most complicated one out of all of them. What we're trying to do here is take in two different strings and then essentially say, take the first guy, add it into my list, take the first of the second string, add it into my new string, take the second of my first string, add into the new string, take the second of my second string, add into the new string, so we get A, B, C, D, E, F, G, H. So we're pretty much kind of going hopping between the two of them and returning this new string. And the way that we can do this here is, let's just go ahead and try to look at our base case that we might encounter. So the only string functions you are allowed to use are length, indexing, or slicing. And then let's see here. Most likely our base case here is if we are encountering strings with an empty length. So if our length of A is going to be 0, what we could try to do here is return a blank. And we can also check if our length of B is equal to 0, and then we can return a blank. Now, how do I actually go ahead and try to create a new string out of this guy? Well, let's just try to look at our logic first. If I go ahead and say print A of 0 here, we'll see I'm getting A and none in these two scenarios. Excuse me. So it looks like I'm getting the, I'm not getting the lowercase a here. I'm getting a lowercase a and then an a, but I'm also getting a none twice. So what I'm going to try to do here next is print b of 0 as well. Let's try to put a of 0 and b of 0 side by side. And now we'll see if I'm doing it this way, I get the capital A and the lowercase n, and then the capital A and the lowercase b from this scenario here. Now an issue here that we might encounter, before we look at that, the next step that we need to try to do here is, how do I actually increase or get to this base case here? Well, again, because this is a list like we're used to, the way that we get to the base case of any list is by returning the list of 1. But an issue here is that this rect string merge takes in these two parameters. So instead of returning the list of an item here, list of 1 to the end, what we're actually going to do is return the remainder of the list of both of these guys until the end. Cool. And it looks like I'm getting A, B, C, D, and E, and F, but it looks like I'm not getting them into a single row. So why is this happening here? Well, what's happening is that I want to make sure that I'm returning, instead of printing, return A of 0 and B of 0 like so. And now if I try to run this one, though, you'll notice that I'm only getting a tuple, and the tuple I'm getting is of the very first guy. So this keeps happening where I'm getting a tuple of it. What I actually did want to try to do is, instead of just returning this tuple, I want to return maybe a string representation of these two. So what happens if I add up A of 0 and B of 0? Now we'll see here that I get A, B instead of the tuple. So now I have A and B put together. This isn't the ending that I want though. What I want to do is eventually return a full string of it. So what I'm going to try to do is return A of 0 and B of 0, and then concatenate all of that onto the remainder of my recursive calls. Now we'll see here that I get A, B, C, D, F, and then Anthony Zoka at the end as well. Cool. So again, this was assignment 7. In general, please review a bit of the less than and hourglass is a good one. And then, of course, the list and the number counters as well.